Okay, today we're going to look at what we call rationalizing the denominator of a radical, and what that means is we're dealing with division questions that don't divide. So before we get to that, let's look at one that we did yesterday. So if we have a division question like I've got on here, 8 root 6 divided by 4 root 2, remember the rule is just divide your front numbers. 8 divided by 4 is 2, root 6 divided by root 2 is root 3, and you're done. So we divide the front numbers, divide the roots, and we're finished. But the problem that happens is not all questions are going to be possible to divide. So if I gave you 8 root 6 over 2 root 5, we can see that we can't divide it. 8 divided by 2 is good, but we can't go 6 divided by 5. So in these cases, when you have roots that don't divide, we have to come up with a different strategy, and that strategy is what we call rationalizing. So what we do with rationalizing the denominator is we multiply the fraction by something in order to get rid of that square root on the bottom. So if you remember back to when we do easy questions like a root 4 times root 4, that equals root 16, or just 4, right? The root 4 times root 4 kind of cancels it out and you just get a 4. So that's the idea, is to cancel out a square root, we need to multiply it by itself. So for this question that I've got on here, in order to rationalize it, we want to times the bottom by root 5. That'll cancel the root 5 that's there. But whatever we do to the bottom, we have to do the same thing to the top. So if we multiply both of these out, you'd have 8 times 1, root 6 times root 5 would be root 30, and then on the bottom we'd have 2 times 1, and root 5 times root 5 is root 25, or just a regular 5. So now when we do this, we'd simplify it, we'd have 8 root 30 over 10. Square root of 30 doesn't break down, so we just leave it the way it is, and 8 divided by 10, we can actually reduce that as a fraction to 4 over 5. So we'd have 4 root 30 over 5. Okay, so rationalizing doesn't necessarily divide. Like in some cases it helps when you're dividing, but what it does do is it gets rid of the bottom square root. It turns that bottom number into a rational number, which is why we call it rationalizing the denominator. Okay, so if you get a question, let's look at a couple here. If you have a question where you get a square root as part of one fraction like that, we never write it as a fraction within a root. So we break that up as to root 3 over root 4. And in this case, we can simplify it. Square root of 4 is just a 2, so we're good. But if I gave you a question that was root 3 over 5 like that, we break it up, root 3 over root 5. We need to times it by root 5, top and bottom. So that would give us root 15 over regular 5. Okay, so the process is the same. You just got to make sure when you rationalize it, you times it by whatever that bottom square root number is. And only the bottom square root. Like if you look at this example up here, we didn't care about the 2. We were only worrying about the square root of 5. Okay, so let's do a couple more examples. So if I gave you 4 root 3 divided by root 10, so we would times it by root 10, top and bottom. So then our fraction on the top is 4 root 30, and on the bottom we'd have just a 10. So now to simplify it, 4 over 10 will reduce to 2 over 5. And we're finished. Okay, so rationalizing, pretty basic questions. Let's do one more, a little bit harder. So if I gave you negative 3 root 6, we're going to divide it by 2 root 3. So we'd rationalize by timesing it by just the root 3, top and bottom. So that gives you negative 3 root 18 divided by 2 times 3. So we'd have negative 3 root 18 over 6. So this one we can simplify. The root 18, we can break it into 9 and 2. So that would be negative 3 times 3 root 2. So that gives us negative 9 root 2 over 6. And we can divide both of those by 3. So negative 3 root 2 over 2 would be our final answer. Okay, and we'll stop there.